Calculocks and the Cooling Porridge. Once upon a time, 3 bears lived in a house in the middle of the woods. One morning, Papa Bear got up really early and started to make breakfast.
This is going to be the best porridge ever.
After a couple of minutes, Baby Bear rolled out of bed.
Dad, I'm hungry. Make me some porridge.
Next, Mama Bear walked downstairs.
Oh, what a beautiful day for porridge. Oh no, the porridge is too hot. Let's go for a walk.
Walks are so fun!
Yay! Papa Bear, don't forget to lock the door.
Whatever, it should be fine.
That same morning, Calculocks was walking along in the woods, searching for 1 minus sine phi theta equals r shaped flowers, and she lost her way.
Oh look, a house.
Calculocks walked into the house to find 3 bowls of porridge.
Porridge, but which should I eat? I know, I'll use Euler's method to see which one is the right temperature.
Calculocks used her super-duper investigating skills to come up with a differential equation that would model the change in temperature of the porridge over time. She figured that the room was about 60 degrees Fahrenheit, and the porridge was probably about 200 degrees. She decided to use Euler's method as a form of linear approximation. She was pretty sure that the porridge would be too hot to eat right away, but she wanted to know how hot it would be in 10 minutes. She wanted to have time to eat it before the owners of the house came home. She started off with a step size of 1 minute. Calculocks started with the initial condition that at time 0 the temperature was 200 degrees. Her step size, or change in time, for each step was 1 minute. She calculated using her initial condition, dt dt. She then multiplied that by the change in time to get the change in temperature. Finally, she added the change in temperature to the initial temperature to get the new temperature, which she then plugged in the next step. She did this over and over and over until she got to 10 minutes and got her final answer. For the medium-sized bowl of porridge, she found a temperature of 109 degrees Fahrenheit. However, that took way too long. For the next bowl of porridge, she used a step size of 2 minutes, and she found that the smallest bowl of porridge would be 105 degrees after 10 minutes. But that took too long, too. For the next bowl of porridge, Calculocks decided to use a really big step size of 5 minutes, so that she would only have to do 2 steps. She found a temperature of 95 degrees, which she thought would be too cold.
Yum, I'll eat the 105 degree bowl of porridge. Ouch, that's too hot. Ow, I burned my tongue. I want to go home.
After a couple of minutes, the family of bears comes home.
Oh wow, this porridge was just delightful. What a great idea to go on a walk.
I can't wait to eat my porridge.
What the heck? Someone ate my porridge!
Look, someone jumped out the window.
What are all these equations? It must have been
Calculocks.
What Calculocks didn't realize in her calculations was that all of the bowls of porridge were actually the same temperature. Clearly, she didn't pay enough attention in calculus class when Euler's method was being taught. In fact, Euler's method is a method of numerical approximation using repeated linearizations. None of the estimates exactly fit the curve. The reason that Calculocks' estimates were different was that she used different step sizes. The step size determines the accuracy. The smaller the step size, the closer to the curve the estimate gets. Because the function for decreasing temperature is concave up, all of Calculocks' approximations were actually underestimates. The real temperature of the porridge was actually greater than 109 degrees. That's why she burned her tongue. Maybe next time, Calculocks will know how to make estimations based on differential equations.
The end.
About the authors. Nick likes mashed potatoes and corned beef. Eliza prefers mac and cheese and raspberries. Kira loves her mom's split pea soup. Aviva prefers Flintstones vitamins.